with Runtime Encryption. Please welcome co-founder and CEO of Fortanix, Ambuj Kumar. Ambuj,
hey.
How are you? Hey, good luck.
Thank you.
All right, your time begins now. Go.
Today, when applications run, they are vulnerable to a variety of attacks. To fix this runtime vulnerability, organizations use layers of defensive tools. However, true security remains elusive, not because of lack of trying, but because modern infrastructures are fundamentally far too complex. It is time to accept this reality and decouple security from infrastructure. So what we have done is we have built a solution that provides deterministic security, not just for the application runtime, but through operating system down to the core, protecting you even from root users. Just like encryption today protects data at rest and data in motion, Fortanix's runtime encryption platform protects data in use even when infrastructure has been compromised. So how is it even possible? We use Intel SGX to run applications inside secure enclaves, isolated from the rest of the system. We do so transparently without requiring any app modification. With the code that you already have, we create a portable security envelope, and that envelope travels with your application, protecting your application wherever the app runs. We make it easy. We provide you with all the components and tools to run your application securely, from persistent storage to trusted networking to secure orchestration layer. We even protect you from threats that cannot be mitigated at SGX hardware level. For our innovation, we have more than 10 patents pending. Our approach is pragmatic and does not fight laws of physics. So we can support any application without constraint with minimal performance overhead. These days, everybody, from parents to politicians, is worried about data misuse. So what if we can create a system that allowed you to process data without compromising on anyone's privacy? Here is one application that analyzes users' messages to infer their personality traits. The user in this example is Elvis Presley. Without any protection, an attacker can shockingly search through memory to reveal private messages between Elvis and FBI Director J. Edgar Hoover. With runtime encryption, that correspondence remains 100% private. Within a short time, we have gained a strong market traction and strategic partners. Dozens of customers are already using Fortanix to secure their containers, keys, and machine learning data sets. Being pioneers in this field, we are close partners with Intel. With Equinix, we have launched a global service that combines our security innovation with their operational scale. With IBM, runtime encryption is now available in public cloud. Our stellar momentum is fueled by a team with technical expertise in securing billions of devices and business experience in scaling companies from zero to hundreds of millions of dollars in revenue. Encryption has been a pillar of hope in the face of constant data breaches and uncertainty. Now, runtime encryption takes it further, allowing new possibilities for secure compute and collaboration that will give tremendous value not only in economic sense, but also for social good. Thank you.
Yeah. Excellent.
Thank you.
Even left 1 second in there for applause, man, for dramatic effect. And it's interesting having one of our judges on the panel as the co-discoverer of Spectre that might have some interesting questions here. So judges, questions?
All right, Hugh, you set that one up. So CPUs can contain vulnerabilities. Is SGX robust enough to depend on?
So we provide best security allowed by Mother Nature. And any useful system is going to leak information, just by definition. Meltdown, for example, melted down everything except for Fortanix runtime encryption platform. Spectre is slightly trickier, but we can patch CPU microcode to protect from that kind of attacks too.
Yeah, what's your view on the major cloud providers in this area, just in terms of AWS, Azure, Google? Yeah.
So we partner with IBM, and as a result, now IBM has SGX machines where you can run your applications containers unmodified with Fortanix. And Intel has a robust roadmap in this direction. And so sooner or later, major cloud providers will have something like this working.
What performance trade-offs should application developers expect? And can you compare that to other potential ways you could do this, like homomorphic encryption, et cetera?
Sure. So just to clarify, we provide both a platform, like Microsoft Windows, and an application, right? For example, our key management that is more like Microsoft Office. So when I compare my key management solution with traditional HSMs, we are 30% faster because of better APIs that our platform provides. For general use cases, performance penalty depends on the use case, but it can be anywhere from 0 to 25%. When I compare with homomorphic encryption allows you to do very simple compute, like search and like basic arithmetics. We can run complete Apache servers, Nginx servers, things of that nature. And even with those use cases, the performance is like 0 to 25%, as I said, which happens to be billion to trillion times faster compared to homomorphic encryption in many cases.
I mean, the platform you've built is the holy grail in a way, which is the ability to run your code, put your data into an untrusted, compromised, evil, under subpoena cloud environment, and not have to worry about it. How much have you actually tested this under fire? Why should I trust the solution and the architecture?
So we have strategic partners like Equinix and IBM. And these are global companies with much bigger reputation than upstart like Fortanix. So they have put us through strong vetting processes where independent reviewers, companies whose sole job is to vet security solutions for against their promises, have reviewed us and blessed us.
What is it actually taking to take an application that you have never seen before into your environment? Is this like a multiple week project, or is it easier to recompile the project using actually those capabilities natively?
We don't even need to recompile. We take your container and produce another container in minutes. So in terms of our contribution, it's minutes, and then you just need to deploy it on your machine and get deterministic security.
All right, we'll have to leave it there. Thanks very much.
Thank you.
Appreciate it. Our next contestant, the only solution to third-party cyber risk management. Please welcome CEO of Cyber